What? Did you take the pill?
Alright, let's look at those
Did
questions.
you take the pill?
No.
So you still have it?
You know that.
Pull out game on.
So you telling me the pull-out game is weak?
Hey,
Pull-out
sir.
game weak?
Thank you, thank
That was
you,
good.
thank you. Okay, so I want to point this out. Can you explain 4, 5, and 6? The answer is no. That's not a specific question. I need specific questions. Absolute value, how to make the tables. How come the first question isn't quadratic? You mean the first table? First set of tables for whoever that is?
I thought it was.
Yeah.
Yes, okay. So we'll look at that. How do you write the equation when you're done finding everything else? So we're going to look at some of those things. Specific reason for the f in the equation for different letters like g of x. Alright, that's a good question. So absolute value is there. Higher score on number 1. Okay, so I'll come back and check this in a second. One thing to be aware of here with number 1. So what is the definition of a parent function? There's a couple of things that you need to be aware of. First off, what determines the type of parent function? The what?
The main operation.
The main operation, right? So you had to say something about a main operation for this number 1. If you didn't say that, you missed points. But what does that mean, a main operation? Like, well, what does that mean we cannot have? Y'all, for a parent function. Up here. We can't have what? There can't be any transformations, but how do we see those transformations in the equation of a parent function? Say again? Addition, subtraction, multiplication, and division. So you had to talk about that there. So what defines the parent function? Well, some main operation. What do we mean by main operations? Squares, square roots, cubes, things like that, without any transformation. So no addition, subtraction, multiplication, division. And then connect that to your example and non-example of a parent function. Caleb, I'm guessing that question was yours?
Huh?
The way you were looking at it earlier?
Oh.
Oh, no? Okay. For the person who asked about how to score higher on number 1, does that make sense? By the way, I talked through things, but unless you earned a 6, maybe you should have made a note to yourself about how to improve that answer. Or continue to sit there blankly staring at me and don't correct your mistakes. So what makes a parent function? The main or defining operation. For example, squares, square roots, cubes. So you have a main operation without what? Transformations, seen through addition, subtraction, multiplication, and division. And I wanted you to connect that to your examples.
So its operation is the function.
Say that one more time.
I wrote the main function.
But its main operation defines that type of function.
I wrote the main operation.
Huh? Did you say anything about no transformations or give an example or a
I
non-example?
gave an example, and I guess a non-example.
I got main operation. I got a 0.
Only that gotta be a straight line. Parent functions are solutions for the operation.
You know what I was talking about.
No, I have no clue what you're talking about. That is a major conceptual misunderstanding.
Oh. The other stuff I just wrote to
The main operation, f of x equals x squared. So you gave me an example, but you didn't show what the main operation was, so I don't know fully that you understand what we mean by the main operation.
Quadratic.
Well, but what is the main operation there? The square. It's a quadratic function, sure, defined by that main operation of a square, and you don't have any transformations there. Or, yeah, and that's what we want to note. No transformations. We see those transformations through addition, subtraction, multiplication, and division. Yes.
You underlined part of my
You underline the part where it says without being transformed by the main operation. What's the issue there?
You can't be transformed by the main operation, you can be transformed by addition, subtraction, multiplication, division. Remember, the main operation is what defines that parent function, and then it's transformed by those transforming operations, right? Addition, subtraction, multiplication, and division. Does that make sense?
I see.
And so we gotta be careful on that language side of things. So if you think you had something close to correct, but you didn't earn those points, let me know and we can talk through it. But yeah, that's the issue there. Any other questions before we move on? Well, just number one, we're gonna look at more of this in a second. Because I specifically saw a good bit about absolute value. And I think some people are confused also with quadratic. And that comes up for number two, f of x equals x squared. And f of x equals absolute value of x. Do not forget, these defining operations mean something. When we square, what does that mean?
Here,
Multiplying it by
itself.
itself, right? Take the time to think through that, because I saw a lot of people here put -2, -4 under that square, because more than likely they typed it into the calculator. But if you type that into the calculator the wrong way, you do get -4. -2 squared, that is -4. But -2 squared, where you're squaring the entire -2, that's a +4. What's the difference?
The parentheses.
The parentheses, but it's more than just that. The calculator correctly understands this as the opposite of 2 squared. That's what this means. And so what's the first thing that's going to happen here?
It's gonna square.
It's going to square it, then multiply by -1. That's what your calculator did, and that's why I got -4. What are your questions about that? So we need to recognize if it's -2 squared, that's -2 times -2, which is a +4. -1 times -1 is 1. 0 times 0 is 1 times 1 is 2 times 2 is. Notice I didn't say squared almost all the way through. I said what that thing means. When we square -2, -2 times -2 is 4. Does that make sense a little bit more so we don't make that mistake moving forward? Okay? But what do we mean by the absolute value?
2.
No, what do we mean by the absolute value? The distance away from 0. How far is -2 from 0?
2.
2. How far is -1 from 0?
1.
0 from 0. 1 from 0. And 2 from 0. So for those of us who struggled with it, what type of function was this?
Absolute.
That's an absolute value. See how -2 is 2 units from 0? -1 is 1 unit from 0? One thing I will remind you and emphasize is, just because I gave you a table here, did you have to stick with the table?
No, you could have graphed it.
You could have graphed it. I saw a lot of people who were much better with the graphs than they were with the tables. Well, you could have made graphs out of this. I saw some people who were way better with the tables than they were with the graphs. With the graph section, could you have made tables out of it? The big thing is you need both the parent function and the transformed to figure out how it's changing. We'll come back to this in a second, because I just want to look at what questions we have in the calculator from here. Toto? I don't know what that means.
Mr. Kenny, if you have Gerald Fritz, could you have him bring his things and come to the office, please?
Yes, ma'am, he's on the way. Okay, I will point out, I know I don't have everybody who responded. There's only so much that I can do to help if you don't respond. So, how do you write the equation once you're done finding everything else? Remember, that's where this came in, and by the way, like, I will leave this up on the board so that if you want to, you can take a picture of this. This is a way that I organize all that information in second and third blocks. I realized this is a little bit more helpful, where I separated out, huh?
Oh.
I mean, y'all did all this yesterday. We just didn't organize it in this format. But if that helps you, you might want to take a picture at the end of class. Quick show of hands if you would rather work on 2 or on 3.
On 2.
Okay, sorry. Quick show of hands if you want to work on 2. Show of hands if you want to work on 3. Okay, the 2s have it. Sorry, guys. But we want to notice that there are both horizontal and there are vertical. Horizontal is going to be found with which variable? X, thank you. So what is happening to my x's?
They're being multiplied by 2.
To go from -2 to -4, is that multiplied by 2? -1 to -2, is that multiplied by 2?
Yes.
So x is multiplied by 2. And technically x values.
Dang, that's why.
So an absolute value.
I put 2x instead of 1/2 x.
Oh. Who said what over here?
I said, with absolute value, you multiply.
Dang.
It's not,
Yeah.
remember, okay, hold on. This is absolute value because of the parent function, right? So the parent function is absolute value of x because outputs are inputs distance from 0. But Omar, that's not why I said this detail. With a transformation, what I'm trying to figure out is what changed from the parent function to the transformed function. Look at it. When I go from -2 to -4, and -1 to -2, and 0 to 0, and 1 to 2, all the way through those x values, the x values are multiplied by 2. That's it. Now, we need to remember that that's the factor, but Anthony already said an important detail. Remember, when it's horizontal, we need the what?
Reciprocal, multiplicative inverse.
Multiplicative inverse. So if that's my parent function, horizontally, I don't want a 2x. This is a detail a lot of us missed. I want a
1/2 x.
1/2x. And you would want to explain why.
Because you have to get
It's horizontal, so you need the multiplicative inverse. Okay?
So we had to put that at the, what is it called?
The absolute value symbols. I mean, yeah, it's the parent function.
Well, I put it as something else and you gave me like a 2.
That means that you got, so remember, look at the rubric. What does the 2 say on the rubric? This is not random, these numbers. What does the 2 say?
Okay, so response is not valid.
Response is not valid, but
justifying your correct response.
you have a decent start on justifying a correct response.
Okay.
Guys, I need y'all to understand, and I need to emphasize this better in the future, the numbers on your sheet aren't random. They're to give you feedback. It's to tell you how correct you are and also how much evidence I see of your understanding. That too is very intentional to say, hey, look, this is incorrect, right? You had the wrong main operation, but there is something there that I see that is correct, and I try to tell you what, right? Each of those numbers means something very intentional. Okay, so Omar, look at these y values. To go to these y values, what's happening every single time?
Add 3.
Adding 3. So y values are added by 3, right? So that's vertical. We want to recognize that. Because it's vertical, where's it going to go in respect to the main operation?
Oh,
Well, in the main operation.
outside.
Outside. So I don't need the inverse, so it's plus 3. Done.
Hey,
That's all I had was
I could have got a
plus 3.
6.
Huh?
That's all I had was plus 3.
But you see how you also needed that detail and you need the absolute value?
Mr. Kenny, if I would
I
have
ain't
put
know how to
1/2
get
x,
it.
I would have got a 6.
I put a 2 instead of a
Okay, but have you learned now so that you can use this to help you improve your understanding before your 9 weeks exam next week so that you can earn a higher score?
Next week when?
Next
Friday.
week.
Next Friday.
Oh, you mean?
Mr. Kenny, You think I'm gonna put one half away, got six. You think
Uh,
I'm gonna put one
Sure,
half?
man.
Depends on your justifying.
Testing.
Alright,
Cause I got a 4.5.
so now, I'm not gonna go all the way through number 4, but I will remind you, what do you need to get started with all transformations?
Parent function.
Parent function, right? Make that parent function table here, right? We already did that one. To go from the parent function to this function, I need you to justify how you're creating it. I saw some people who went straight from that table to the parent function, or to the transformed function, but did not justify anything. So I couldn't really let you earn a high score because I didn't see the evidence of your thinking. The other thing I want to point out, because I saw this for a lot of students here, this -2 is multiplied, correct?
Yeah,
Yes?
so that's a vertical.
So, well, one, it's outside, so it's vertical, but because it's multiplied, we know it's a,
Reflection.
ooh,
It's negative.
it's negative, so it's a reflection, but it's also a,
Dilation.
you have to talk about both of those things. Yes, you could say the y values are multiplied,
Those don't always be a reflection dilation.
no. The y values are multiplied by -2. The negative creates a reflection, right? F equaling 2, or the absolute value of F equals 2 creates a dilation, a stretch. You had to have both of those. Remember, the negative creates the reflection. That factor other than 1 or 0 is what creates a stretch. Well, creates a dilation. And so when I look at the y values in the table, what should I have done to those y values?
Multiply by -2.
That's it.
I just think you need a little bit more practice, that's all.
We've had too much practice, to be honest.
We just started on it though.
No, we've done it for over 2 weeks.
It been that long?
It's been that long.
What the world?
Yep. All this week, all last week, and 3 days for the week before. And yes, I know we need to practice a little bit, but we did some more of this after that. And that's why we also did this organization, or this summary of everything, so that you can fix these mistakes. And so notice the y values are multiplied by -2. What do we want to say about the x values?
They added by 3.
Right. Now, why is it added instead of subtracted?
Because you gotta get the inverse.
It's horizontal, so you need that inverse, right? So you would also want to say it's a translation to the right 3. Alright, last detail before we move on. This number 6 here was probably the most difficult one on here, because there actually were 2 vertical transformations. But it's not terrible if you think through what you see, right? This is just the graph of that absolute value set of points over there. You can create the table, and I would highly encourage that, but what do you see happening to this point? Went to the
Left 2
And?
up 4.
up 4. So translation, left 2, and up 4. But that would still have it looking like this, correct? So what else happened? Which direction?
So you wouldn't put down 4 into the right 2?
It wasn't down 4. It went literally up, didn't it?
Yeah. I think I'm seeing it backwards.
So, and it does, the order really doesn't matter. If it's horizontal, right? So first off, it'd be x plus 2, because it's inside the main operation, I need the inverse. And it'd be up 4, it's vertical, so I don't need the inverse. And then I need a vertical reflection. That's it. Right? So vertical reflection, translation left 2, translation up 4. Notice how I'm showing those connections to those equations.
Oh, so then that would be a 6 right there. That's all you had to do.
I would say 5 to 5.5.
Alright, yeah. So just show.
But
just
no, remember, it's not just about the number. Look at what the rubric says. Where's your rubric? You don't have it out? Can you borrow Jenny or Soraya's and look at theirs real quick? Anthony.
Huh? Oh,
No, the calculator, that made my soul cringe. What does a 5 say?
oh. Let me see, hold on. Give me a second. Alright,
Read out of 5.
a 5 says "Look, solution respond is valid, but there is a slight or minor error in the justification or the justification is missing.
Details.
Alright,
Alright.
Mr. Kenny, I'm
So, notice a 5 is a strong score. That's very strong evidence of your understanding, right? But you made some small error in your justification or you're missing some details, right? Kyle, what does a 5.5 say?
Solution or response is valid, but the justification is slightly incomplete.
Right. It just means that you're missing some small details that would be important. Like, for example, here, a small detail that we're definitely missing is, well, if it's left 2, why is it plus 2? Well, you would want to indicate the horizontal transformation needs the inverse. That would be a detail that we should add here to get it closer to a 6. Right? The last question I saw that people were asking about, remember, this is just function notation. The reason why we would use different letters here is to indicate different functions. That's it. That's the only reason why there's different letters. Because what you can end up doing, and we'll do this later actually, you can actually add those two functions together.
What?
Well, f of x is just 3x plus 2, isn't it? G of x is just x squared. So just add them together.
How you supposed to add that up?
Well, there are no like terms, so it would just be that. Or you could rewrite it in the standard form of x squared plus 3x plus 2. Yeah, I'm not saying you combine anything. I mean, they're literally added. One was a line, one was a parabola, and I add them together. All right, need your textbooks out. I need you to go to M1 dash, I think we're on 141, if that sounds right, hopefully.
Yes.
M1 dash 141.
Mr. Kenny, why you still don't put like a total grade on the top?
Because if I put, whether it was a 65 or a 70 or whatever, that's the only thing you're going to look at. If I put that you had a 58 on there, you would just look at it, you would crumble it up and throw it away and never look at it again. If I put that you have 100, you would just put it in your notebook, be proud of it, and move on, right? Like, that's not what I want. I want you to look at those individual scores and not just, hey, it's a 2 or it's a 3.5, and I need to be better about emphasizing this. I want you to use the rubric to figure out how well you understand that question. See what you understand and what you don't understand. What evidence am I seeing of your understanding?
He said one.
I know that game of
Yes, Kyle.
looking at
Yes,
a
yes,
grade
yes.
and moving on, because I played that game too, and I don't want y'all to play that game, because that's a terrible way to learn.
So, can you think your way is the best way to learn?
I think I have things to improve upon, but I know that there are elements of how I teach that is definitely better than what you've learned in
Is
the
it a
past.
boy or is it a girl?
Because yesterday is the first time we've really studied Algebra 2, and I know that we're still struggling with all those Algebra 1 concepts, but if you didn't already know it coming into my class, then we didn't really learn it as well as we needed to the first time around, right?
So now we don't waste the time.
Huh?
We waste the time.
Unfortunately.
You better tell her.
And we're not going to finish all of Algebra 2, we're going to do the best we can though. Okay? So, remember, what we started yesterday is translating and dilating functions by non-constant values to create higher degree functions. And today we're going to start getting into the relationship between the linear factors of a function and its zeros. Now, one thing I want to point out here is we struggled with some of this yesterday. Is that fair to say?
Yeah.
Yes. I want you to get your sheet, or look at this page, and I do want you to write something down, because Miss Courtney pointed this out after class, and she's 100% right. We only looked at these functions algebraically and graphically. Was there anything else we could have created to help make sense out of this, though?
A table.
Yeah, guys, I don't know why I failed you in that regard, but we should have made a table here. The original function, right? This function right here, like if I pick the x value of -4, what's the y value?
Wait, huh?
If I pick this x value of negative 4, what's the y value?
3.
3, thank you. Whew. The x value is negative 3. The y value is 3. X value is negative 2. Y value is 3. Negative 1, 3, 0, 1. Okay, I'm gonna stop there. Literally, what it told us to do was to take the 3 and do what to it?
Add X.
Add x. There's my 3, right? Isn't that my x value? What's 3 plus negative 4?
Negative 7.
Negative 1.
That's my new y value.
Oh,
But did the x change at all?
No.
No. That was it. That's all we were doing. Right? Negative 4, negative 1. If you were struggling with the graph component of yesterday, the table may have really helped. We take the x value is not changing because it was a vertical translation, but then we add x. What's 3 plus negative 3?
No.
Right? We take this 3 and we add its x value. 3 plus negative 2.
1.
3 plus negative 1.
2.
And so please don't ever forget that we can definitely create tables or any representation to help us out. Does that give us the same exact graph as what we saw yesterday? Can that table help us organize our information?
yeah.
Very much so. Hopefully for some of us that are more comfortable with tables, we're seeing how we get those points more clearly, right? Remember, it literally told us that it was it was translated by x, so that would mean that the y value is translated, right? But the x value stayed the same, just the y value was translated. Do you have any questions about that add-on, or does that help us see details a little bit better?
Yeah.
Okay, so Kylie's feeling better. I appreciate that. No one looks more scared, so that's good. So where did we get to in this yesterday?
We did the points.
We did some points? So let's do a similar thing here to help us out of making that table. And one thing I'll say is, instead of creating two different tables, you can also make one table, right, like this, because are the x values changing? Nope. Just the y values are, and remember, they've told us that g of x equals x times f of x. And so we can write that at the top to help us organize this. Start there with negative 6. So negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. Which that seems like a lot. But when this x value was negative 6, what was the y value? What's this y value when x is negative 6? Very close.
Negative 3.
Remember it's down, so we need the negative 3. When x is negative 5, what's the y value?
Negative 2.
Negative 2. And then?
Negative 1. 0. 1.
2.
So it seems like a lot, but I mean, because there's a pattern, which remember math is the study of
Pattern.
types of relationships, it becomes pretty straightforward. And so, I'll wait for you to write that down. Kylie, did you get that pen?
Yes.
So from here, literally all it is
X times up.
x times the f of x. And remember it's multiplication, so what transformation is that? Dilation, right? So we want to keep that in mind. But negative 6 times negative 3 was 18. Negative 5 times negative 2.
10.
Negative 4 times negative 1.
4.
Before we get any further,
0.
is there anyone who has a question about how I am getting these new y values?
No, sir. No.
Thank you, Kylie. Thank you, Jakayla.
No, sir.
Thank you, Anthony. Alright. So I'm going to pause.
So you just multiplying the x times f of x.
Because remember, that's literally what they told us to do,
Okay.
right? They said dilate, so choose several points on f of x and dilate each by multiplying by the x value at that particular point. So we dilate by x. Yes, ma'am?
But even after you multiply those points and you get your new value, do you understand what the coordinates of your new point is?
That is
So
good.
after you multiply, what point are you actually
Good.
gonna graph?
Because remember, these are the x's that go with these
New Y value.
new y values. So that is one reason why you might want to make two different tables, right? But
Right.
you don't have to if you can recognize the x and the g of x go together.
But the X all don't never change though in this situation.
Right, which is why it's okay to make one table. Notice for all the stuff that we did previously, you would have to have two tables because the x values did change.
Alright, bet.
Oh, so this is something like, it's a new topic.
-1.
So, hold on. To say it's, well, first off, like, everything in math is connected. Are we doing things slightly differently? Yes. But literally, we're still multiplying, so it's still a what?
Dilation.
Dilation. So we're still dilating, it's just, remember we talked about it yesterday, it's by non-constant values. When we dilated before, it was like just by a 2 for everything. Now, we're dilating by x.
-1, 0, 4, and 10. So it went up, down, it went
And
up,
around.
down, stayed the same, then down again, then up.
Anyone see a shape there?
Parabola.
Yeah.
It was like that last time.
Yeah, because this is the same one that we did yesterday.
Oh,
So we should have that parabola there, right? Notice I couldn't fit some points on there, so I didn't stress it.
But you got more than
Yeah, most of them up there to show that parabola. And I think this is where we left off yesterday, was this number 2. Did we write this out a little bit?
We
No.
didn't do that.
We stopped when
Okay.
we were making the points, and then the last time we said was dialing by
So,
the constant
Mr.
being
King.
new point.
Correct.
Those new points, is that like the transform function?
Correct. Well, so these are the outputs for the transforming function, and here's my inputs, because those didn't change. So we only transformed the y values.
So they
The ones
transform.
in the middle right now don't even matter.
Well, they helped us get the transform.
Yeah.
So basically it changed from a linear to a quadratic.
Perfect.
perfect though.
We're going to talk about why that should make sense in a second, right? But we do want to notice that, yeah, it changed from a linear to a quadratic. We went from f of x equals x plus 3 to, and notice they say it right here, write the equation to represent the new function g of x. Well, g of x is x times f of x. What could I put in the place of f of x?
Any of those. Put 18, 10, 4, 0.
Those are only that particular output. F of x, what can take the place of that f of x? Not 3, you're close.
5.
Remember, you can only substitute something in that is equivalent or the same. What is f of x the same as?
Wait, oh,
Negative y.
6.
no.
Y.
That is y, but, y'all, there's a symbol up here that literally means the same.
G of x.
Dude,
Look right here.
yo, quick.
What is f of x equal to?
Y.
It's-
X plus 3.
Oh.
F of x is equivalent to y, but Omar, that's the very beginning that we had this line of x plus 3, didn't we? So what is f of x equal to?
X plus 3.
So what can I substitute in for f of x in number 2?
X plus 3.
There we go, thank you.
That's not what I understood from your question the very first time.
I can tell.
I have it right.
So I reworded it.
Say x plus 3.
Because it was x plus 3, it's not just 3. Because if it was just 3, it'd be x times 3. And that's not what it is, it's x times x plus 3. Remember, this would actually be a linear function, but we can very clearly see it's a,
Parabola.
for the shape, which is what type of function? Quadratic. Does anyone see anything here that would indicate that this is in fact quadratic?
Huh?
Do you see anything here that might make, it should make sense that it's quadratic?
Yeah.
What is it? Where do you see the square? I don't see
Yeah,
that
that
yet.
one you got
You need one?
Yeah.
Yeah,
Oh, we don't have one?
No.
Sure.
The 2x.
yeah, yeah, okay.
Well, this is being multiplied,
You gotta
right?
put it outside the parentheses.
Oh, so both of them x's do mean it's squared though.
What, I mean, it's multiplied, so what can I do with this x?
Just move it on the inside.
Ooh, don't,
Well-
not just move it,
Multiply.
distribute it.
So now it'll be
So what is x times x?
x squared
X squared
plus 3.
plus 3x.
X.
Remember, it's x times 3 as well. Still think we don't have the square?
Yeah, we got enough.
Right now. But we had it originally, we just needed an equivalent form, right? Does anybody recognize this form of a quadratic function?
Standard form.
That is standard form. Just the c would understood to be,
0.
that is standard form. By the way, I will point out, these things are being multiplied, right?
Yeah.
Is there a mathematical word that we've learned that starts with an F to indicate multiplication? Factor? That might be what form then?
Factor.
Factor form? I could have rewritten that x as x minus 0. That is still x, isn't it?
Yeah. X
Yeah.
minus 0 plus x
Times,
X
plus 3.
plus 3.
is that factored form?
If we.
Wow.
What?
If you
Rewrote it?
yeah, if you written it like that.
This?
Mm-hmm.
Yeah, I mean, that's equivalent, isn't it? Notice you can get standard form or you can get factored form. Either one is perfectly acceptable.
What about quadratic?
Factor form more simple though, right?
It's your choice.
I mean, yeah.
I can't tell you one's more simple than another because, as I said, some people on the understanding check saw tables way better than they saw graphs. Some people saw graphs way better than they saw tables. It's your choice. Pick your own adventure. Okay? So, does it make sense that this is quadratic now?
No.
Right? And so what we did leave off on yesterday was dilating by a non-constant creates a new function.
I remember that. Yep.
Yeah.
Hey, can I go to the bathroom?
No, never again. You're never allowed to use restroom.
Okay,
I was being sarcastic.
I am.
All right. Now, you don't need to draw this, but I am going to draw the line y equals x up here. There's the line y equals x. Before we answer the next question, because I'm going to have you do this in your small groups quickly, what is another word for a zero?
Roots.
Roots, which how can we identify roots on a graph? Those are the,
X-intercept.
anybody have a question about that detail? So, I want you to notice, number 3 says, identify the zeros of g of x. How are those related to the two linear factors? Talk with your small group. I want y'all to figure out within your small group what the zeros are for that parabola, and then we're going to come back together in about 2 minutes.
How many zeros is that?
That's your, well,
It's 2.
think back to what Anthony just said. A zero is also known as a
Root.
root, and graphically, how do we identify roots?
X-intercept.
The x-intercepts. So talk about with your group, figure out where we see those x-intercepts. Let's get to talking.
You talking about that line you just drew, right?
No, it says g of x. Remember, g of x is the parabola.
Help you along if you graph those points. You understand how I graph those points?
How are these?
Make sure you graph your points. Okay, otherwise a lot of this doesn't make sense.
You know that you cannot, it's really hard to figure this answer out if we don't have our parabola. Guys, it's going to be almost impossible to answer this question if we don't have that parabola drawn. Make sure you have that there.
I got mine drawn.
Well, the only issue you have is right here. It almost looks like it's flat, but it's still going to, it's just going to dip down a little bit and then come back. right? It's a bracket. So any points down this, you must not be flat. See how I came down below those 2 points? Points on the graph. I mean, we just so make sure you pick the points off here and graph them.
No way, I thought we
One really important point. Notice there was, and so it was -2, -2 as well. So that's also a point. So the vertex is somewhere in between those two.
That's all he ever says to me anymore.
Does that make sense?
That's all he says to me anytime. Like, oh, okay.
Huh? That's right, 0. Yeah, because 0. Right, when I did x times f of x to get the output. So talk with your groups, come on, we need to get those x-intercepts. We need those zeros in those groups. Okay.
Just look around.
Do you see any other zeros? Well, remember, a 0 is also shown on the graph as an x-intercept. So are there any other x-intercepts? So are there any other zeros? Okay, so you gotta focus on the question of how are they related to the two linear factors? Thank you. Thank you. Oh, what? All right. So I ran out of room, but this is going to be where I write number 3. So what do you know, Omar?
Alright, so one x-intercept is -3, 0.
All right, so let's stop there for a second. -3, 0. Now I need you to notice that's an x-intercept. What would be the 0 then?
Why?
No,
I
it's just
mean,
a point.
Well, the point is the x-intercept. The 0 would just be x equals -3. Notice it's the x value. The 0 is just the x value. Okay?
And then the other one is 0,
0, 0. That's an x-intercept. And so the 0 or the root would be x equals.
-3.
0.
But
We already did this one. We're doing this one.
so when you put it in factor form,
Uh-huh.
that -3 become the inverse.
Well, remember everything horizontal acts the inverse. So instead of +3 or +3, it'd be a -3. But you can also just see it on the graph. It's right there.
So,
What are you confused by?
What was we looking for? I thought you wanted to see like how,
Identify the zeros.
so that's it. That's all we have to do.
Yes.
and then you gotta say how they're related.
Well, then, right, so you could have just looked at the graph. Now you could have identified your root 1 and your root 2, right? So the zeros are -3 and 0. Those are the zeros. Because those are the x-intercepts. We need to look at it algebraically and graphically. Before I move to the second part of this question, what are your questions?
No.
Okay, none for Chicala, but I'm glad that you have none. Just wait a second to let those who do have a question ask, and then if no one says anything, you can say that. No questions? Alright. So, how are these related to the two linear factors? I've drawn the two linear factors up, or the two lines up there, right? I've drawn, or this already had y equals x plus 3, and this is the y equals x. So how are those x-intercepts, those zeros, associated with the linear factors?
Because
They both cross into them.
through,
So they, what do you mean they both cross through it?
they intersect through, whatever.
So those are,
The x
The
values
x-
are a point of the line.
yes, not just a point of the line, they are the same what?
Vertex.
That's the vertex. Remember, okay, the purple,
Oh no, man.
that's the x-intercept of the parabola, right? That point is also the x-intercept of this line.
Also, they both got the same, they all got the same x-intercepts.
Right. That's all it's saying here is the linear factors
I knew that.
share
I did.
The same x-intercepts. Slash zeros. So that's what we want to notice here, and that's why the factored form works, because the intercepts are the same.
Mr. King,
Yes, ma'am.
you know how we got the x-intercepts from over there?
Mhm.
And you said they are zeros are roots, right? And when right there, when you put R1 and R2, when those be the...
So remember, the only thing you have to be careful about is it's x minus r1. Well, a times x minus r1 times x minus r2. And remember, that's why we said right here, r2 would have to be a negative 3.
Okay.
Right? And r1 would be a 0. Notice that matches the zeros. It's a good question. I like those kinds of questions. What are your questions at this point?
Nothing, because I don't know. Let's go to the next page.
Kyle's like, I just want to move on, Mr. Kenny, but learning takes time, so we want to be slow and intentional. Going once. Going twice. So, by the way, I mentioned this up here earlier. Notice how it has this question of how can you use a table to help organize your calculations?
What would you need?
That's what we did, right? Those tables can be powerful. Okay, we're going to move through some of this somewhat quickly so we can get to a little bit more practice with Miss Courtney's part of this.
Oh, this the same graph, isn't it?
Maybe. What do y'all think?
It look like it.
Yeah.
What are the two factors? X plus 3 and
Yeah,
y equals x, right? Okay, same factors. So notice up here, the graph shows the product of the linear factors used to create the new function g of x equals x plus x times f of x. So again, that's g of x equals x times x plus 3. As you analyze the graph from left to right, why do they specify left to right?
Because you start.
That's how you read a book.
That's how you read it. Well, that's how you read a graph, just like how you read a book. Okay. Consider that the new function changes from decreasing to increasing at those points, or at that point. Notice that point, negative 1.5, negative 2.5 is here. That's negative 1.5, comma, negative 2.25. Label that point. That is a point. Negative 1.5, comma, negative 2.5. Why is that point important?
It's the vertex.
It's the vertex. We can go into more detail about that in a second.
It's a decimal because it's like not exactly like
It's not on the intersection of that grid. Yeah. Well, it's a decimal just because that is the vertex. Like if you were to examine that on a graph, that's what the vertex would be. Okay. Alright. So, I want you to notice that what we're about to do is analyze two intervals. First off, I want you to go ahead, I'll leave it there for now. I'm going to talk about two things really quickly. You see right here where it says that the new function changes from decreasing to increasing at this point? So, I'm going to draw a vertical line through here. You don't necessarily need to, but I'm going to draw this vertical line. Why do you think it's saying that it changes from decreasing to increasing? What do we see? What's decreasing? But what do you mean the curve?
The parabola.
Okay, but I want you to think about something.
A decrease ain't.
Hold on. You see this x value? What's that x value? Negative 1, 2, 3, 4.
This one?
I want you to look at this x value. What's that x value?
Negative 3.
So are the x values decreasing?
Yeah.
I thought negative 3 was bigger than negative 4.
Oh, it's increasing.
Okay, now pause. I'm not saying it's increasing. I am pointing out, do you see how the x values are increasing? But what is this y value? Y is equal to 4. What is this y value?
0.
So what did decrease?
The
The
y.
y values. I need you to write this down when we say decreasing. When we talk about decreasing, we will write about the domain values. By the way, domain, which variable is domain?
Yes.
X, right? So the X values for which the range, which range values would be my, thank you, for which the range values are decreasing. I need you to be very clear about that. That is one of the most common mistakes that students make in Algebra 1, Algebra 2, and Pre-Cal is they do not realize that we're going to talk about the X values for which the Y values are decreasing.
You put wheel for
Yeah, you put.
When we talk about decreasing, we will write about the domain values for which the range values are decreasing. Same for increasing.
We talk about decreasing.
Okay?
So then on when increasing, the X's go on decrease and the Y go increase.
No, because we always read from left to
Right.
right. If we're reading from left to right, the X values are always what?
Increase.
If you're going from left to right, the X values are always increasing. Look right here. That X value is 0, the Y value is 0. But look right here. That X value is 1, the Y value is 4. The X values are always going to increase. When we talk about increase and decrease, we're talking about the Y values increasing. And to help that, yes sir?
And it's gonna always increase because that side, the right hand side,
Well, what's always going to increase?
the Y value.
Not necessarily. They are in this case. But if you have a concave down parabola, what are my Y values doing right now? Increasing, and then on the right side they are decreasing. So you need to look at the graph and you need to look at the Y values to see if those Y values are increasing or decreasing.
But would they be increasing in that
If you leave
concave down?
In
Right.
concave down, right, so here's my vertex, notice that's where it stops, or where it changes. Look at your Y values, look at my finger. The Y values are increasing. After here, they are decreasing. Okay? So, a quick thing I do want to note, the way that I will always talk about it to make sure that we're trying to be clear about this is, instead of just saying decreasing and increasing, what I will talk about is domain intervals. And I'll explain more about why I use the word interval later. But domain intervals over which the function decreases. That is a mouthful and it's a pain in the butt for me to say, but I have found that it helps students be better about identifying those intervals. So here, I would say domain intervals over which the function increases. Why do you think I start out with that statement of domain intervals? Instead of just saying decrease or increase, why am I starting out with that statement of domain intervals? So that you know you're talking about the X.
Cause you talking about the domain operation.
Dude, he just said.
The domain interval is, we're talking about the X values.
Oh, why you just say anybody? Oh,
Right?
yeah.
I did. Alright. So,
Good.
this is where you will want to mark up your graph a little bit. Number 4A asks us to do what?
Consider the interval between x is -8 and the x is -3.
Okay.
And then explain why the product of the negative factor results in g of x being positive.
So we'll talk about that in a second, but I want you to see, this is what we mean by an interval. An interval means everything in between here. That's an interval. Every single possible number in between -8 and -3. So when I talk about domain intervals, I'm talking about everything from one value to the next. Okay? So let's break down this question. Explain why the product of the two linear factors, so we're going to go back to g of x equals x times x plus 3, results in g of x being positive. Here's g of x. And remember, g of x, is that my input or my output?
That's your output.
That's the output. So how can we see that g of x, the output, is positive?
How?
Look at look there. How do we know, looking at that graph, that g of x, the output, is positive?
We don't know. I think it's negative, because we on negative value.
What's negative though?
The x's,
But-
the domain interval.
The domain interval is negative.
Yeah,
But remember, g of x, is that my inputs or my outputs?
that's your output.
So we're not talking about x, we're talking about the y.
Y.
I already told you that g of x is positive. How can we see that g of x, the y, is positive?
It's, outside of,
It's outside the domain intervals.
No. Listen to the statement again. Think about this. G of x is my what?
Your y.
The y's. Look at the y's.
Oh, they increasing. The y's are increasing.
No, because we always read left to right, so that's decreasing. What is the y value here on the x-axis? Y equals. So how do I know that these y values are positive?
Because of the first y is equal.
This is,
The rest of them are
how?
What does it mean for a number to be positive?
over 1. Over
Over
0.
1 is what?
Over 0.
It's over 0? So how do I know that these y values are positive?
Because we see that one is 0.
They're above 0, right?
That's it.
That's a part of it. You gotta know the idea of positive right there, okay? So we want to start out that g of x is greater than 0. That means it's positive. That's not really the focus here though. The focus is explain why the product of the two linear factors results in g of x being positive.
Okay.
Look at these values. Are these positive?
No, they negative.
They're both negative. So why is g of x positive if both of these are negative?
We're talking about the parabola.
So we're talking about y values, not anything.
These y values are negative.
Oh.
Remember, the way that we're getting g of x is by multiplying x, this purple function here, the bottom one, times x plus 3, the top one here. Right?
So long as x is positive,
The x's aren't positive though. These x values are negative. Negative 8 to negative 3. Think about this.
a negative times negative.
Why were these positive? Say that one more time. Thank you. Say it.
A negative times negative.
Negative times a negative creates a what?
A positive.
So both of these are negative, right? So that negative times this negative created a positive.
Oh. I guess.